Hello and welcome to another video. We are going to be talking about the standard equation of a circle and going through some notes and examples together in this video. We'll start out with a little bit of a warm-up looking at two circles graphed on graph paper pictures, and we were looking for the radius and the center of each circle. So if we looked at circle number one, if you kind of look at where the circle is at on the graph, it looks like we have a center right here. And if we're looking for the radius of that same graph, well, we could do the radius this way to the left. We could do it down to the right or straight up and down again. So if we're looking for the center, well, that center point is 2, 1. And the radius would be equal to 2. Looking at the second circle, well, this one's a little bit obviously in a different place. And if we kind of draw a diameter here and draw a diameter here all the way across the circle, where they're crossing at this point right here, which that point is 1, 2, 3, 4, 5 to the left. So it'd be -5, 0. And our radius would just be half of either of those diameters, and that would be only equal to 3. And we can see that that is going to be a good skill to have when we're trying to figure out by looking at a circle what the equation is, and vice versa if we were trying to draw a circle as well. Our main objective here is to kind of do both sides of one process to find the center and radius of a circle if you are looking at an equation, and then by looking at a circle, how would you get the equation? Both sides of the same math coin, you could say. And that's our main objective. We basically have a circle here graphed at the origin, and we want to think about how would that equation be written, and we're basically going to look at it as the Pythagorean theorem, as I mentioned in a previous video. So I could mark the center as that point right here, and I know that any of these points, like I could say that any of them are the point I'm looking for. So I could say this point, and then I could kind of just draw a triangle where we have x and y and r, and that's just Pythagorean theorem. So if I run and write the equation for this circle, I would just have x squared plus y squared is going to be equal to my radius squared. Well, if I want to figure out the radius, I don't want to do a diagonal line. That's much more challenging. I can just count from the middle up boxes 1, 2, 3, 4, 5. And I could use this radius right here in green instead of the red one I drew earlier, and know pretty easily that it's 5 squared. But I did in a previous video, instead of writing 5 squared, I would want to write it instead as 25. And I would rewrite that instead as 25, which is obviously equal to 5 squared. And that would be if you have any circle that is centered at the origin. It's always going to be x squared plus y squared, and then just whatever your radius is from there. We have an example here, so you may want to try to write out what the equation for this circle might be before I go through it. So try that and pause the video now if you want to do that. Now, if I wanted to write out the equation, well, I know that it's centered at the origin still. So I can see, well, my circle is going to be 0, 0. And that means I could write it out as x squared plus y squared automatically. And then it's just a matter of figuring out what my radius would be. And I'm just going to count upwards 1, 2, 3, 4, 5, 6, 7, 8, 9. Squared would be my radius squared. And so my equation would just be x squared plus y squared equals 81 as my final answer for this circle. And we want to write that out as our final answer. Depending on what practice assignment you're working on, you might get it incorrect if you don't have the fully simplified version where 9 squared is made into an 81. We're just looking here at a note that I showed in a previous video, but this is the standard equation of a circle. And the important things to remember is that the h and the k there at the center are always going to be the opposite numbers of what you see in the parentheses because of the subtraction part that you see in the equation in front of you. And you always need to make sure if you have r squared in the end, the square root of that number on the end is going to be the r value that you're looking for as your radius. And it may not always be a whole number or an integer, but it is always going to be a positive answer for r, since we're talking about distance here and not a negative or positive direction. We're now going to do the opposite of what we just did. So we're going to look at the center and the radius and determine the equation of a circle using the equation we just saw on a previous slide. So let's start with number 3 here. So if we have a center of 8, 3, we know we're going to have x minus 8. 8 is obviously the x part of that coordinate point. And we have y minus the 3, which is the y part of it. And that's equal to 3 squared. And we want to just write that as a 9 as our final equation. So we could even just erase the 3 squared now and keep it as a 9 as our final answer. Moving on to number 4, we have a center of a circle at -2, 5 and a radius of 4.1. So right away we see some different stuff going on with a negative value in our coordinate point for our center. And a non-integer, we have a rational number 4.1 as our radius, which is going to create some different issues for us to handle. So we're going to do first, write out our equation and then try to simplify it. So we're subtracting a -2 for our x value, parentheses squared, plus the y part is y minus 5 squared equal to our radius of 4.1 squared. So we got to think about how we can simplify this. First, we know that if we have 2 subtraction signs, we can kind of do a plus plus action right there and write it instead as x plus 2 squared plus our y part being unchanged, nothing we needed to do for that one, squared, and that is equal to 4.1 squared, which if we put it into our calculator, it comes out to about 16.8. And that would be in green right there, the final answer for number 4. And so now if we go down to number 5, we have even more different stuff going on. We have a negative in our coordinate point and also a 0. But then we're talking about a diameter instead of a radius. So let's think about what we need to do here. So if our diameter is 8.3, that means our radius is exactly half of that. And if we find exactly half of 8.3, that would give us 4.15. So we know our radius now to use. So let's start building our equation. We have x minus 5 squared plus our y value is a little weird because we have a 0. So I'm just going to write in a y minus 0 squared and then equal to 4.15 squared. Now I want to definitely simplify this because I know that if I have a -0, I really don't need that involved at all. And our 4.15, that's got to be squared. So we can try to simplify this now. Our first part is unchanged. It's still going to be x minus 5 squared and we still then have a y involved in that second part, but the 0 is gone, so it's really just now a y squared, since y minus 0 just equals y. And that means we're equal to 4.15 squared, which is going to be equal about 17.2. And that will give us the equation of that circle with a center at -5, 0 and a diameter of 8.3. In example number 7, we're going to reverse the process from those last previous questions and look at this circle, which is not centered at the origin anymore, and try to determine what the equation would be. So if we grab our pen, we want to look at where the center is, like you practiced earlier. So we know that that is the center, so we can maybe write it over here to the side first. So that point is -4, 0. And we can write that over here for later. And then if we count just straight upwards, 1, 2, 3 spaces, we can tell that our radius is equal to 3. And then let's write out our equation from that. So we have x minus a -4 squared plus y minus 0 squared is equal to 3 squared, meaning that our final answer is going to end up being x plus 4 squared. And then we're going to add our zeros gone, just a y squared to this. And then it is going to be equal to 9, giving us this blue equation as the equation of the circle graphed to the left. And number 8 example will be the last one of this video. We have a slightly bigger circle graphed, and we want to determine the equation of this particular circle. So if we look for our center, we can kind of see that our center is right here, and that point is 2, -2. So let's write that up at the top, 2, -2. And from that center, let's just count up 1, 2, 3, 4, 5, 6 spaces, meaning our radius is equal to 6. And let's kind of write out our equation from that. We have x minus 2 squared, the x part of that point with the x, plus y minus -2 squared is going to be equal to 6 squared. And then lastly, we just got to simplify that a little bit. Our first part right here is the same, so we can just write that again. Nothing changed about that one. But our second part, we have 2 negatives in a row, so we can make that into pluses. And we can write it as y plus 2 squared. And then lastly, 6 squared is equal to 36. And that in purple is the equation of that circle graphed to the left. And that concludes the video on the standard equation of a circle, where we have determined the center and the radius of circles that are graphed. We have determined the equation of a circle graphed at the origin. We have created equations using the center and the radius, and then determine equations of circles graphed at various places away from the origin. Thank you for watching.